Today we are going to be going through section 12.6, which is about converting conics between graphing form and their general form. So at this point we have looked at all the conic section types and we have figured out how to graph them and write their equations, and we're going to look at one last type of an equation. So what we are looking at here is the general form of a conic section. So for any conic section, any of the four we've talked about, the general form is this equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So this is just the generic form or the general form, and it allows us to do a couple different things. So the first thing we can do is, when we're looking at this, since it's the general form of any conic section, we can use the value of the discriminant to determine the type of conic section that we're talking about. So when we do the discriminant, remember that's b squared minus 4ac. So your b and your a and your c are all coming from this equation. So we're looking at the coefficients on the x squared term, the xy term, and the y squared term. If the b squared minus 4ac, the discriminant value, is greater than 0, so it's a positive number, that means that our conic section is a hyperbola. The equation would be representing a hyperbola in that case. So if we have a positive discriminant, that represents a hyperbola. If our discriminant, so our b squared minus 4ac, is exactly equal to 0, then that represents a parabola as our conic section. And then finally, we have if the discriminant is negative. So if b squared minus 4ac is less than 0, one of two things can be true. It's an ellipse if the a and the c, so the coefficients on the x squared and the y squared term, are not equal. And if they are equal, so if a does equal c, then it's a circle. So based on our discriminant value, we can determine what type of conic section we're looking at. So we're going to do some practice with that here. So looking at example 1a here, I can see that my a value, which remember from up above, the a is the coefficient on the x squared term. Well, when I look at this equation, I don't have an x squared term, so that means my a value is 0. I also know that the b, which is the coefficient on the xy term, is not in this one, so it is also 0. And my c value, which is the coefficient on y squared here, would be 1. So when I plug those into the discriminant, I do b squared minus 4 times a times c, and that would equal 0. So then I'm going to look above again at my table. When my discriminant is 0, that tells me that I am working with a parabola. So that equation that we started with, y squared plus x plus 4y minus 2 equals 0, is a parabola equation. All right, let's look at another one here. So this time we have x squared plus 4y squared minus 6x minus 16y plus 9 equals 0. So my a value here, my coefficient in front of x squared, is 1. My b value, my coefficient on the xy term, we don't have an xy term, so it would be 0. And my coefficient on the y squared term would be 4 for the c value. So again, I plug those into my discriminant. B squared minus 4 times a times c would give me a discriminant of negative 16. So a negative discriminant is this special case up here. So since I'm looking at that special case, I need to determine if a and c are equal or not. So I can look at the a and c from up above, and I can see that they are not equal. So we would say a is not equal to c, which means that we are working with an ellipse. All right, let's look at 2 more here. So in this equation, c, my a value, my coefficient on x squared, is negative 9. My b value, again, I don't have an xy term, so it'd be 0. And my c value is 16. So plugging those in, I have b squared minus 4 times a times c. And when I multiply all those together, I get 576. So I have a positive discriminant. Looking up above, a positive discriminant means that I am working with a hyperbola. All right, and then our last example here. In this one, my a is 1, my b is 0, and my c is 1 as well. All right, so plugging those in, b squared minus 4ac, that's going to give me a discriminant of -4. And again, remembering that when my discriminant is negative, I'm either working with an ellipse or a circle. In this case, my a is equal to the c. They're both 1, the coefficients on those terms. So that means that I am working with a circle. So one thing we can do from general form is we can determine what kind of conic section we're looking at. So what we're going to do next is we're going to start with a circle. I would encourage you to pause the video and try these steps on your own and then come back through and check your work. So in our generic form here, we have it listed out there and we are trying to convert it into our graphing form, which we know from previous lessons is that equation. All right, so let's go through the steps that we would need to do that. So starting in our generic form or our general form, we would want to isolate the constant. So remember, the constant is the number without any variable attached to it. So to isolate that, I would move it to the other side by adding it. So I would have the equation 2x squared plus 2y squared plus 12x minus 8y equals 6. So I have isolated that constant on the other side away from all of the variables. All right, the next thing I'm going to do is I'm going to get my like terms together. So I'm going to get my x's together. I have a 2x squared and a 12x. And then I'm going to group my y terms together. So I have 2y squared and a minus 8y. And that still equals the constant term of 6. All right, the reason I grouped those like terms together is so that I can start to factor and get into that form of graphing for this circle. So when I look at my x terms, I've got that coefficient of 2 out in front. So I'm going to factor that out so that I have a leading term of x squared in that parentheses. And then I'm going to do the same thing with the y's. I also have a leading coefficient there of 2 on the y terms. So I'm going to factor that out. And that's going to leave me with this equation. All right, now we did that in order to complete the square so that we can get it into that graphing form. So I'm going to carry my 6 down and my 4 down, and then I'm going to complete the square. So remember, to complete the square, we take the b value, divide it by 2, and square it. So that would be 9. So I would want to add 9. And for the y terms, I would want to do the same thing. So do that b divided by 2 squared. And that means that I'm adding 4 to this side. So from our equation before, we knew that it equaled 6. And then remember, when we complete the square, we have to, if we're going to add something to the left side of the equation, we also have to add it to the right. So remembering that we added 2 times 9, which is 18, and we added 2 times 4, which is 8. So keeping that equation balanced on both sides by adding the same thing to both sides. All right, so now that we've completed the square, we are able to factor those trinomials into perfect square binomials. So x squared plus 6x plus 9, that factors to x plus 3 squared. And y squared minus 4y plus 4 factors to y minus 2 squared. All right, so we are very close now to that graphing form of a circle. The last thing we need to do is divide both sides by that factor out in front. So I'm going to divide everything by 2 so that we get rid of that coefficient out in front. So that's going to give me a final equation of x plus 3 squared. plus y minus 2 squared equals 16 when I divide it by 2. So that would be my graphing form of a circle. So I could tell my center, I could tell my radius, and I could have everything I need for that. All right, so let's go on to our next conic section. This one is an ellipse. So as a reminder, we have our graphing form up here that we're trying to get to. And in this one, again, I encourage you to pause the video and kind of see if you can figure out what's going on in each step and then come back through and check your work. We start off with our basic equation. So again, that equation is in general form. So again, I could use my discriminant to figure out what it is, and I would figure out that it's an ellipse. So I would start the same way we started the circle. I would move that constant term to the other side. So I would isolate the constant on that side. And then the next thing I would do is I would rearrange the equation so that I can group the like terms together. So I've got my x terms together, I've got my y terms together, and then again, it equals that constant. All right, the whole point in grouping those like terms is so that I can start to get to completing the square. So in this case, I have factored out those leading coefficients that were in front of x squared and y squared, so that my factors now have x squared and y squared in front of them. All right, then I've used that to complete the square on both sides, remembering that whatever I multiply by over here is really a number that's being distributed to. So we just have to remember that if I'm adding a number on both sides, I have to add the entire number to the other side as well. So I have multiplied that factor and added it to the right side of the equation as well. Now I can finish completing the square by writing my trinomials as perfect square binomials. And then finally, to get it into graphing form, we need it to equal 1. So in this case, we need to divide by a constant, so a number, in order to make the equation equal to 1. So in this case, we had 144 over here, so we had to divide everything by 144 in order to get the equation equal to 1, like we know an ellipse needs to be. So when I divided those by 144, that's where you're seeing the denominators of the fractions come from when we reduce those fractions. And now we have our ellipse graphing form. So again, I could find my key points, my centers, and all that good stuff where my focus would be. Okay, let's go on to our third conic section. And in this case, we are going to be working with a hyperbola. So we are trying to get our general form of the hyperbola into the graphing form of the hyperbola. So we've got our steps over here. Let's see if we can work through them and figure out how to convert this. So we've got our generic form. We would do the discriminant, figure out what it is. In this case, it would be a hyperbola. So I would start the same way I have started all of them. So I would isolate that constant term by moving it to the right side of the equation. So now my equation would equal 19. And then again, I would group my like terms. So I would move the negative 4x squared and the negative 48x together. And I would get my 25y squared and my negative 150y together as well. And I do that so that I can start the process of completing the square. In order to complete the square, I'm going to factor out that leading coefficient so that my leading term is now x squared. So if I divide by negative 4, I'd be left with x squared plus 12x. And if I divide out the 25 from the y terms, I would be left with y squared minus 6y. So really just rearranging here, not simplifying really yet at all. So then copying down what I already have, I know that I have 12x's, I know that I have negative 6y's, and I know that my equation equaled 19. So now we're going to complete the square for each part. So again, taking that 12 divided by 2 and squaring it. That's going to give me 36 on this side. And that 36 is really being multiplied by -4. So I would be adding -144 to my other side. Completing the square of the y's, taking 6 divided by 2 squared. That means I'm adding a 9 in there. But again, remember that 25 is being multiplied by the 9. So I'm actually adding 225 to that side. So when I factor and simplify, I can take those completed square trinomials and factor them to perfect square binomials. When I do that, I would get x plus 6 squared, and I would get y minus 3 squared. All right, so again, on this one, we need to be able to get our equation equal to 1. So to do that, I am going to divide each side by that constant. In this case, it's 100, so that I am getting that right side equal to 1. So when I reduce those fractions, I would have negative x plus 6 squared over 25, because 4 over 100 reduces to 1 over 25, plus y minus 3 squared over 4, because 25 over 100 equals 1/4. And now my equation is equal to 1. So then the last thing we do is we just rearrange it so that it's in proper graphing form. So in this case, it would be y minus 3 squared over 4 minus the x plus 6 squared over 25 equals 1. So that would be how I convert a hyperbola from its generic form into its proper graphing form. All right, let's move on to our last one here. So our final one is the parabola. So again, we have our graphing form up here that we are trying to get to. And we are taking our generic form and getting it into that graphing form. So we start with our regular equation. So our equation is in general form. Now, when you look at this one, it's a little different with the parabola equation. In this one, rather than isolating the constant like we have, in the parabola, we want to isolate the x and y terms that have a squared variable. So we want to get that y squared in this case alone. If you had an x squared, you'd want to get that alone. But we're trying to get it by itself over there with its like terms. So once we've done that, we can see that we are getting rid of that coefficient again. So we're going to factor to get that leading term of y squared in the parentheses. And then we can tell by adding that 9 and then the -63, we have completed the square on both sides, remembering that we're really, when we're adding 9, we're adding -7 times 9, so that's where that -63 is coming from. Once we've completed the square, we can factor that completed square trinomial into a perfect square binomial. And then, because my x term is negative, I need to convert that. So I am going to divide everything by -1 if that x or y term is negative, so that it's not negative anymore. So I divide both sides by -1. And then I rearrange so that it's in proper graphing form. So I get the x plus 9 on the left side and then the squared y term on the right side. So just flipping the order there. And that is how we convert everything into its graphing form from its generic form. We'll see you next time.